Hello students, I am Nilanjana Sanyal, an online math tutor from India. Welcome you all to my channel NS Online Math Classes. Now, as you know, we are solving questions on binomial expansions where in the power is not a positive integer, it is a rational number. And in our today's session, we will be seeing that the expression whose binomial expansion we will be doing will be a rational function. What is a rational function? We will be knowing about it. So stay tuned till the end and we start with our today's session. Okay, so the first question says, find the coefficient of x square in the expansion of, this is what is known as a rational function. You see, you are having an algebraic expression in the numerator and you are having another algebraic expression in the denominator. When you have this type of a situation, means it is a fraction and you are having one algebraic expression in the numerator and another algebraic expression in the denominator, it is known as a rational function. Okay, we will be knowing about rational function and how to convert rational functions into partial fractions later on. For solving this particular question, we do not need the partial fractions. We can handle this as it is. Okay, so let's start with our answer. So 1 minus 3x raised to the power of 3 over 1 plus 2x raised to the power of 2 can be written as 1 minus 3x raised to the power of 3 times 1 plus 2x raised to the power of negative 2. Okay, these two are getting multiplied together. Okay, and we have seen how to find the coefficient of the term containing x square where two binomials were getting multiplied, but in that case both the binomials were having a positive integer power. But over here one is having a positive integer power whereas the other is having a negative integer power. But we know how to expand both of them. So let's do that. Okay. This will be containing 4 terms. It will be a finite series, this first one. But for this we will be having an infinite series. So first of all, let us write all the 4 terms because there will be only the 4 terms, though I very well know and you all know as well that we won't be requiring all the 4 terms, but let us write all of them as a revision. Okay, so 1 minus 3x raised to the power of 3, it will be starting with NC0, that is 3C0, which is equal to 1 times 1 to the power of 1 to the power of 3 minus 0, which is 1 cube, that is 1, and minus 3x raised to the power of 0, which is also equal to 1. So the first term will be 1, second term will be 3c1, which is 3, times 1 raised to the power of 3 minus 1, that is 1 square, which is 1, times negative 3x to the power of 1 plus 3c2, again a 3. Now it will be 1 raised to the power of 3 minus 2, that is 1 raised to the power of 1, which is 1 again, and this time it will be negative 3x raised to the power of 2. Let me put a big bracket over here. Okay. And finally it will be negative 3x raised to the power of 3. So these will be the 4 terms from the first binomial expansion. And what will be the second expansion? It will be an infinite series, but we will be taking few terms. Now we need, how many terms we will be needing? X square, we need the coefficient of the term containing x square. It can be a single term or it can be multiple terms. We will be getting the coefficients of all the terms containing x square and we will be adding them. That is what we used to do previously when the power was a positive integer, right? So the same thing we will be doing over here. This is x to the power of 1. In order to get x square, we should be having a term containing x from this part. Okay? This is x square, so we should be having a constant term from this part. Okay? And then for this x to the power of 3, we should be, in order to get x square, we should be having 1 over x from this term. But we won't be having any 1 over x. But can we have x square from this term? Okay, let us first of all find the first few terms of that series. Okay, then it will be very easy to visualize. So, and this is, remember this was a plus bx raised to the power of n, where n belonged to the set of rational numbers, and the expansion was r equal to 0 to infinity in CR, and b over a times x raised to the power of r. And b is over here equal to 2 and a is equal to 1. So b over a will be a 2 or positive 2 or simple 2. So it is 2x raised to the power of r. Okay. So when r equal to 0, in C0 is 1, 2x raised to the power of 0 is 1, so the first term is 1. And these two are getting multiplied. Second term r equal to 1, in C1 is n, and what is the value of n? It is negative 2. It is negative 2 C1. So, since the r value is 1, we will be having 1 factorial, and since the r value is equal to 1, we will be having only a single factor in the numerator. This is the denominator r factorial. In the numerator, we will be having a single factor which will be equal to n. The n value is equal to negative 2. This will get multiplied by 2x raised to the power of 1 or simple 2x. Okay, this is the second term. So we see these two can get multiplied together to give us x square. Fine. So what is the third term? For the third term, r value will be equal to 2 in C2. So the denominator is 2 factorial, and since r equal to 2, we will be having 2 factors in the numerator. The starting factor will obviously be equal to n, which is equal to negative 2, and the second factor will be n minus 1, that is negative 2, negative 1, minus 2, minus 1. Okay, and this should get multiplied with b over b over a times x raised to the power of r. r is 2 and b is also 2, so 2x raised to the power of 2. Okay, so this is a term containing x square. If we multiply this x square with this constant term, we will be getting a term containing x square. Okay, And if this is a constant term, this should get multiplied with this x square. So we do not need this, and we very well knew that we will not be needing this x cube, because this will not be giving us any term which will be having x in the denominator. But since there are only 4 terms, so I have written all of them. Okay? And this will be just going on. It will be continuing. Next term will be having x cubed, then x to the power of 4, and so on. Okay? So it is an infinite series. Now we have to get the terms containing x square. So this one gets multiplied with, this one gets multiplied with this part. Okay? So it is 1 times, now this is negative 2 and this is negative 3. So negative 2 times negative 3 is positive 6. Positive 6 divided by 2 factorial is 2. 6 over 2 is 3. And 3 times 2 square is 4. So 3 times 4 is 12. Okay. So it is 12 x square. This is one of the pairs that we should be taking. 1 times this part. Negative 2 times negative 3 is positive 6 divided by 2 is positive 3 times 4 is positive 12. Next, what we can do is we can take this part, this one, and we can multiply this with this term. Okay, so it is plus 1 times, this one is 3 times negative 3 whole square is 9. So 9 times 3 is 27. So 27 x square. Okay, and finally we will be multiplying these two. Okay, so this one is 3 times negative 3 is negative 9x. So it is negative 9x times, this one is negative 2 times 2x. So it is negative 4x. Negative 4x. Okay. So this is equal to 12x square plus 27x square, and this is negative times negative is positive, so it is a positive term. Positive product, 9 times 4 is 36. 36x square. Okay. So 12 plus 27. 37, 39. 39, 69 and 75. Okay. So 75 x square. And we are asked to give the coefficient, not the term. Okay. Therefore, our answer will be only 75 and not 75 x square. Okay. So this you have to be careful about. If they ask for the entire term, you give them 75 x square as the answer. Else, if it is the coefficient, then you have to give only 75. 75 is the coefficient of x square. Okay. So since we are done with the first question, let us move on to the next question. Now this says, find the first three non-zero terms. That means there will be some zero terms also, terms which will be equal to 0, of the binomial expansion of this part. So let's start with our answer. So this is under root, that is cube root of 1 plus 2x divided by 1 minus x. Okay. So this can be written as 1 plus 2x to the power of 1/3 times 1 minus x to the power of negative 1/3. Okay, and we know how to expand both of them. So let us expand, and they are asking us to give the first three non-zero terms. So we do not know how many terms do we require, how many terms will be 0, we have no idea. But first of all, since they are asking for three non-zero terms, let us at least take 4 terms, okay, for each of these two binomial expansions. And if we require more of them, then we can get the others as well, because both of them will be infinite series. Okay, so let us start with the first one, 1 plus 2x raised to the power of 1 over 3. A is equal to 1, b is equal to 2. Okay, and what was the expansion? It was r equal to 0 to infinity in CR and b over a times x raised to the power of r. This was the expansion. Okay, so let us start with the first binomial expansion. It is, first of all, r is equal to 0. For the first term, r is equal to 0, NC 0 equal to 1, and this part is equal to 1, so the first term equal to 1. Second term, r is equal to 1, so it is, the denominator is 1 factorial, the numerator will be only 1 factor, and that will be equal to n, which is equal to 1/3, times b over a, which is equal to 2, and 2x raised to the power of 1, which is 2x. Okay, and third term, it is 2 factorial. Now we will be having 2 factors. The starting one is n, 1/3, and next one will be n minus 1, that is 1/3 minus 1, times 2x raised to the power of 2. Let us take one more term as at least, r equal to 3. So it is 3 factorial, 1/3, 1/3 minus 1, 1/3 minus 2, times 2x raised to the power of 3. Okay, plus dot dot dot, it is an infinite series. This should get multiplied with another infinite series. It is, in this case, a is equal to 1 and b is equal to negative 1. So we start with NC 0, which is 1, and b over a times x raised to the power of 0 is 1. So it is 1, and then r equal to 1, so the numerator is equal to 1 factorial rather, and in C1, which is the n value is equal to negative 1 over 3 times negative x raised to the power of 1, which is negative x, okay, plus 2 factorial negative 1 over 3 negative 1 over 3 minus 1. There will be 2 factors because r is having a value of 2, and negative x whole square, okay, and then it is plus 3 factorial negative 1 over 3 negative 1 over 3 minus 1 negative 1 over 3 minus 2 times, this is in the numerator of course, times negative x to the power of 3, okay, and plus dot dot dot. So this is equal to, now we simplify, 1 plus, this is 2 over 3x, this one is 1/3, okay, let me write them, half times 1/3, and 1/3 minus 3 over 3 is minus 2 over 3 times minus 2 over 3 times 2x whole square is 4x squared plus 1 over 3 factorial is 6. Then it is 1 over 3 negative 2 over 3. This is 2 is 6 over 3. 1 over 3 minus 6 over 3 is negative 5 over 3. Sorry. 5 over 3. And 2 cube is 8. 8x to the power of 3. Okay. And plus dot dot dot. And the second one is 1, and then this is negative and negative, it is positive, so it is x over 3 plus or minus, this one is minus whole square, that will be a plus sign, and this is minus, so it is a plus. So half times 1 over 3, and this is negative 4 over 3. So and we have seen the minus signs cancel, they become a plus, so it is 4 over 3. Okay, and x square plus 1 over 3 factorial is 1 over 6, and this one is what? This one is negative 1 over 3, this one will be negative 4 over 3, this one will be, this is negative. So this one will be negative 7 over 3. So, and this is also having a negative sign. So again we will be having a positive value. So it is 1 over 3, 4 over 3, 7 over 3, x cube, okay, plus dot dot dot. And now we may we may simplify the terms. It is 1 plus 2 over 3 x, and what happens to this part? It is a minus sign over here, I am seeing. So we have to put a minus sign. It is 4 over 9 x square. 4 over 9 x square. And this is a plus sign. Fine. So, and I can cancel these two. So this is 1, 2, 3, 4. So that is 81. And this is a plus. So it is 5 times 8 is 40. So it is 40 over 81 x to the power of 3. Okay. Plus dot dot dot. This is getting multiplied with 1 plus x over 3, and these two can get cancelled, and we will be having 2 over 9 x square. Okay, so it is plus 2 over 9 x square, and then coming to this part, this is 2, this is 3, and this is 14. 2 times 7 is 14. So fine, and this is a plus positive number. So it is 14 over 3, 3, 3, 3. So it is 81 x to the power of 3. Fine. And they have asked us to give first 3 non-zero terms. Okay, the first term obviously in the ascending powers of x. So the first term will be having the power of x as 0, or it will be a constant term. Obviously 1 times 1 will be giving us the constant term. So the first term is 1. Second term should be containing x to the power of 1 or simple x. How can we get x? When this one is getting multiplied with 2 over 3x. So it is 1 times 2 over 3x is 2 over 3x. And this one is getting multiplied with this plus x over 3. So this is the term containing x. Next will be x square. Power of x is 2. So how to get x square? This one multiplied with this gives us 2 over 9 x square. This one multiplied with this will be giving us minus 4 over 9 x square. Okay. And also these two can get multiplied to give us x square. So 2 plus 2 over 3x times x over 3. So these are the only way that we can come to x square. Okay. And we do not know, okay, let us check whether we have got the 3 terms, but whether all of them are non-zero or not, let us check. So let us keep some space and let us write over here in case we need another one. So first term is 1, this is not a non-zero, this is a non-zero term. This is 2 over 3x plus 1 over 3x is 3 over 3x, which is equal to x. So the next non-zero term is x. Now coming to the x square. 2 over 9 x square minus 4 over 9 x square is minus 2 over 9 x square, and this is plus 2 over 9 x square. So this term is equal to 0. So we cannot take this one. Okay. That is why they have asked for first 3 non-zero terms, because this is obviously this is the third term, but this is equal to 0, so we cannot use this. We cannot take this. We have to go for the power of x as 3, x cube. We have to take the term containing x to the power of 3. So how to get to x to the power of 3? 1 times this one. So 40 over 81 x to the power of 3. Again 1 times this. So plus 14 over 81 x to the power of 3. And then we can do what? We can do x squared times x. So plus negative 4 over 9 x squared times x over 3 plus this one 2 over 3x with 2 over 9x squared. Okay. So plus 2 over 3x times 2 over 9x squared and can we have, these two and these two. Yeah. So these are the only ways that, in which we can get the power of x as 3. There is no other way possible. So these are the only ways. So now let us get the value of or coefficient of x to the power of 3. So this one is plus x to the power of 3. So what will it be? 40 over 81 plus 14 over 81, and this is minus 4 over 27, and 27 times 3 is 81. So it will be minus 12. 4 times 3 is minus 12, negative 4 times 3 rather, over 81, and this one is 3 times 9 is 27, and 2 times 2 is 4, 4 times 3, so this is plus 12 over 81 x to the power of 3. So these two will be getting cancelled, and 40 plus 14 will be equal to 54. Okay. So this is equal to, and of course it will not be ending, it is an infinite series. So we have given just the first 3 non-zero terms. So it is 1 plus x plus 54 over 81 x to the power of 3. These are the first 3 non-zero terms. Okay. So students, this brings us to the end of this session. We meet again very soon. Thank you for watching this video till the end. Please like, share, subscribe and comment if you find this video helpful. Please do subscribe to my channel. It will be motivating me to make more math videos of this type. So bye for now.